Hello friends, this is Jim with Science Talk. In this video, I wish to share with you some news about plants in relation to the changing climate effects on plants as well. The first story is loss of unregarded forests is at danger level. Now, unregarded is another way of saying intact forests. 3 new studies highlight the value of the world's unregarded, intact forests and the dangers they face as the climate changes. The world's unregarded forests are at risk. Intact forests is now being destroyed at an annual rate that threatens to cancel out any attempts to contain global warming by controlling greenhouse gas emissions. Trees in the tropical regions are dying twice as fast as they did 35 years ago. Human-induced climate change is a factor. So we have 2 studies that look at this. A third study has highlighted the value to humanity of intact forests, while estimating that 4/5 of the Earth's remaining woodlands are now in some way degraded by human activities. This figure, researchers caution, is probably an underestimate. All 3 studies confirm the value of forests to the planet and underline the increasingly dangerous rate of loss. An international team of researchers report in Nature Communications that they made a computer model of the planet's atmospheric conditions. They included natural and human-triggered aerosols, volatile organic compounds, commonly referred to as VOCs, greenhouse gases, and other factors that influence temperature. Another factor is albedo. Albedo is the term that is used to indicate the capacity of terrain to absorb or reflect solar radiation. So, for example, we have the ice sheets in Antarctica. The ice sheets of Antarctica have a high albedo, meaning there's a high reflectivity, reflectance of the incoming solar radiation back out into space. So the higher the albedo is, the more of the incoming solar radiation is reflected back to space and not absorbed. So on the flip side of it, the lower the albedo, the more the solar radiation that comes in is absorbed by the ground. Which is why with the disappearing sea ice, instead of the sea ice reflecting that solar radiation back into space, we now have open water that heat now is absorbed because of the decreased albedo. So that's an important factor to include in the modeling. So these researchers tested their model against Earth's temperature record since 1850. And they ran it again, but with a hypothetical forest-free world. The result was a significant rise of nearly 1 degree centigrade in mean temperature. In other words, today the planet would be almost 1 degree warmer on average if there were no more forests. So says Paulo Artajo of the University of Sao Paulo in Brazil. That's the first study. The second study, which can be found in the journal New Phytologist, reminds us of just how complex trying to conserve forests can be. So this study looked at some of those hazards and analyzed that. They looked at rising temperatures, increasing CO2 levels, fires, more powerful destructive storms, insect infestation, and the impact of woody vines, which are known as lianas, in South America at least. They found that trees in some areas were dying at about twice the rate they were 35 years ago. Now, just before I continue, we're seeing something similar here in Alaska. I'm referring to insect infestation. The spruce beetle, kind of a nasty looking beetle, black, and it's one of these very long appendages. is spreading north. They're making it to the Fairbanks area. Typically, they would be found in the Anchorage area. Anchorage is about 360 miles south of Fairbanks, or about 6 degrees latitude. But historically, the winters have been so cold in Fairbanks that they precluded the spruce beetles surviving. Even if they laid eggs, the larvae, would not survive the harsh winters. Well, winters in Fairbanks, relatively speaking for Fairbanks, are not as harsh as they used to be. This is starting to allow the spruce beetle to move north, expand their range, and gain a foothold. So, as the climate warms, we can start expecting to see this sort of stuff of creatures from the tropics and subtropics expanding their range further north and south, depending which side of the equator, but more towards the polar regions. So going back to the study here, Nate McDowell of the U.S. government Pacific Northwest National Laboratory says that no matter how you look at it, trees in the moist tropics will likely die at elevated rates through the end of the century relative to their mortality rates in the past. So, this is alarming, and what is needed is we need to preserve the forest, because if I have a forest, and let's say the forest occupies, and I'll just throw out a number here, let's say it occupies 10 square kilometers. Okay? If I now compare the 10 square kilometers of forest to 10 square kilometers of grasslands or savanna, the forest will take in more CO2 from the atmosphere, just on simple biomass, more biomass. So they're able to draw down more CO2 from the atmosphere than the grass or the savannas would be able to. But yet, what are we doing? We are cutting down the forest and replacing with farmland. So not only are we not helping draw down the CO2 levels, we are increasing the CO2 levels, because you cut down those trees, that CO2 that was in the tissues there becomes, instead of a sink, is now a source. It's added to the environment. Plus, we're burning the fossil fuels, we're cutting down the trees that can draw down the CO2. So we're kind of creating a bad positive feedback loop for ourselves. Now, positive feedback loops means a system that keeps exacerbating itself, getting worse and worse. It does not necessarily mean a good thing. It just simply means it's a cycle that gets worse and worse. Negative feedback loops are corrective in nature. They cancel out, they oscillate around in a mean condition. In addition to the healthy forests absorbing the CO2 from human activity, burning fossil fuels, they can also help reduce regional temperatures. Okay, so repeated studies have confirmed this, that conserved forests deliver many benefits. Some of these benefits are indicated in the journal Nature, Ecology, and Evolution. Forests cover about 25% of the planet's land surface, but over the past 3 centuries, Earth has lost at least 1/3 of its natural tree cover due to human expansion, and then more than 80% of what remains has been affected by human action. These same forests absorb about 25% of carbon emissions from human activities. They play a vital role in stabilizing local and regional weather, as well as reduce the risk of drought. You have an extensive root system. They can absorb the water. The water can be held in the soils. Grasslands, if you get a lot of rain, it tends to run off because their root system is not developed or not structured to hold on to a lot of the water enters the soil. So then a lot of that runoff, a lot of it evaporates back out. But also, like anything else, forests, there's a lot of what's called transpiration that takes place. Transpiration is basically the trees and the plants breathing. It's the loss of water vapor through the stomata, which are the holes on the underside of the leaves. There are a lot more of it, so when they release all this water vapor, it helps contain the vapor in the area for the cycle of precipitation and so on. Grasslands and savannas, when you look at the amount of stomata, it's not as much as in the forest. So therefore, when it loses the water to transpiration, it's more likely to go elsewhere. The water vapor is likely to be traveled on air currents to another region, and therefore there's less water vapor. You start having a drying up situation. The other important thing is that intact forests are home to higher numbers of species. In other words, biodiversity is greatly increased in forests than on savannas or grasslands, or even compromised forests. As well as many of our medicines are from tropical plants in the forest. And we are losing many species that we do not know all the benefits, the potential medical discoveries that could be found. It's another reason to preserve, so that we could find useful medications and medicines out of these species. Okay, the next story involving plants. Mountain plants head for the peaks. Mountain plants are heading uphill with climate change. There seems to be room at the top for more alpine species. Well, we have to have a cautionary note here. It may sound good, I say, whoa, no, plants are expanding their range. But what happens to those species already at the high elevations? They get displaced. And where do they go? We see something similar with, this is altitudinal migration. We see something similar with latitudinal migration. Flora and fauna are both moving north. Well, they're moving north to higher and higher latitudes, but they're doing what? They're also displacing the creatures and organisms found at those latitudes to point to where do those organisms go. So it's not what it seems on the surface. The number of species on the highest European mountains has multiplied five times. Data gathered over 145 years from 302 peaks shows that the count of wild plants that have colonized the highest zones has increased 5 times faster than during a comparable decade 50 years ago. And as I just alluded to, this may not in the long run be good news, because the enriching of the high life is unequivocally linked to global warming, changes in precipitation, or in nutrient supplies. These factors are not enough to account for the growth in alpine colonists. More than 50 scientists from Denmark, Norway, Germany, France, Austria, UK, Italy, Switzerland, Poland, Spain, Slovakia report in the journal Nature that such change has potentially far-reaching consequences not only for biodiversity, but also for ecosystem functioning and services. The finding was possible because European botanists and biologists began assembling data on the plant growth at the highest sites in the 1870s and have maintained their databases ever since. Well, that's just great. We have 145 years of data. We can go back and analyze it. So this is important information, and it was really excellent that we have this information going so far back. The scientists found that between 1957 and 1966, period of 9 years, or 10 years if you included the endpoints, the average number of species on the 300 peaks increased by 1.1 on average. Okay, that's number of species. It's not a percentage. Number of species. Between 2007 to 2016, on average, 5.5 species made it to the top, right? 5.5 divided by 5 is 1.1. There's your five-fold increase. The study does not, so far, suggest that new species have displaced the original residents, but plants adapted to the conditions on the highest peaks may soon run out of options as the mountains themselves get warmer. Another thing to consider, back to albedo. The snow on the mountaintops are melting. That warms up the mountains, where before the snow would reflect the heat off the mountaintops, keeping it a little cooler and helping those organisms adapted for those conditions. Well, we're losing that snow pack is melting, so the albedo is now being reduced, making warmer conditions. That's not favorable to the organisms traditionally found there. In this case, we're talking about the flora. Some of the species which have adapted to the cold and rocky conditions on mountain summits will probably disappear in the long term. They have nowhere else to go, and they can't develop or adapt rapidly enough to be able to compete with the new arrivals, which tend to be taller and tend to be more competitive under warmer conditions. This is a statement by Manuel Steinbauer, who led the research. He did this research while at the University of Aarhus in Denmark, but is now at the Friedrich Alexander University Erlangen, Nuremberg in Germany. The species that move upwards often come from grassland above the tree line, but they can't survive everything on the mountaintop, so it's not certain there'll be a threat to all the existing species up there. The local soil conditions and microclimates may also play a role. So in other words, the possibility is that the range of the flora already at the highest elevations might be reduced. Whether or not to be totally displaced is yet to be seen and remains to be seen. Mountains, of course, are natural laboratories because of the isolationist tendencies. A little difficult for a pollen to go from mountain to mountain unless there's an agent involved, such as insect or birds or mammals and so forth. Conservationists and biologists have repeatedly warned that mountain ecosystems are more vulnerable to climate change. Scientists have measured the rate at which plants, birds, insects have gained in altitude in the Swiss Alps and in the Andes. They have observed changes in the mix of alpine flowers and even detected diminution in the body size of alpine chamois with increasing temperature. So as I said before, this is very similar to the concept of latitudinal displacement. But at least with latitudinal displacement, there's not the isolation tendencies that you have on a mountaintop. So there are more options for the organisms to move to other areas. But like everything else, the activity of humans has an impact on what we do. And we're seeing this. Nothing we do goes without effect. We are part of the ecosystem, not separate from it. So I wanted to bring those two stories involving plants. If you like the video, please share your video. Please share this video with others. Please go on social media. Tell them of this channel and the work that I do here. Please subscribe and hit the bell button so you receive notifications whenever I drop a video. I hope you will consider going to patreon.com/Science Talk with Jim Massa and subscribe and support the work I do here. If you're already a patron, at Patreon. I thank you for your continued support. Thank you for your time. We'll talk soon.